Yesterday in science, well, we spent some time reviewing the experiment from a couple days before, where we took that vial of cold water, put it inside the vial of hot water, and we saw how the particles kind of bumped into each other. Yesterday I referred to it as the cheese touch, right? You have something with a lot of energy and it has the cheese touch on something with lower energy, and so it gives it some of its energy and it heats it up. And we said that the red water had some energy and it gave to the plastic of the vial. The plastic of the vial heated up and it gave some of its energy to the cold water. The cold water gave some of its energy to the thermometer glass, and the thermometer glass gave some of its energy to the red liquid inside the thermometer, which caused it to expand and go up the thermometer, and we say, hey, it warmed up, right? Okay? Can somebody explain the word conduction to me? Because we said all of this really is talking about conduction. What does that mean? And there's 17 blank faces. We talked about it for 2 days. What's conduction, Luke?
It's when like something transfers energy to another thing.
In a certain way, though, because the sun transfers energy to us. That's radiation, right? Conduction transfers energy, but it's in a different way. How?
I'm gonna tell you what conduction was.
That's what I'm asking.
Conduction occurs when two particles at different energy levels and they make contact.
Oh, that's really brilliant. I can tell you came up with that all on your own. Conduction is energy transfer between molecules as a result of contact. Okay? Contact is the main thing. You got some molecules here, they bump into these molecules, suddenly these molecules have more energy, right? The cheese touch. Caleb.
I like the color of that water.
Say that again?
I like the color of that water.
He likes the color of the like blue.
This like aqua blue. Have you ever seen water like that?
No.
Oh, there is water like that. You go to the right places, like in the Caribbean, and like nice vacation spots. The water's that blue. Ooh, it's pretty. Braylon. Yeah, that's kind of nice too. Okay, so here's an example of what that looks like. You've got this solid side of the pot. That pot is being heated up. So all of these molecules are, which solid molecules, they just kind of vibrate back and forth, right? But the liquid water does more like this sort of thing, where they kind of flow over or rotate around each other. And so when this gets hot and vibrates more aggressively, I guess, or faster, it bumps into these liquid particles, and there's conduction because you've got this contact happening, and therefore the water is going to heat up inside that pot that's on the burner. Does that all make sense? Okay. I want to take you through one other thing, I think. Let's see, we talked about that, we talked about that. We'll get to that in just a second. All right, with all of this whole idea of conduction, really, this is in the grand scheme of the Earth, right? How does energy transfer to the air? We've talked about how radiation comes and heats up the soil, it heats up rocks, heats up a lot of different things in the Earth. How does energy now transfer to the air? So I'm going to give you a sheet of paper that looks like this. Let's see if we can show it there. There it is. Okay. Instead of this being a full-blown experiment where we get out hot water and stuff, I was going to do that, but I think we're going to just watch a video instead of the experiment, just for the sake of time, because there's some other things I'd like to get to as well. But let's do this as if it was us doing the experiment. So when you get this half sheet of paper, lazy person experiment, kind of. Does that mean a lazy person? Yeah, I guess a little bit. There you go. Up at the top, you'll notice that this sheet of paper is called Conduction Through Metals. Have you ever picked up like I don't know, maybe somebody was making a bowl of soup for you, and they heated up the soup. I like my soup really hot, like scald my mouth so that inside of my mouth burns off kind of hot. I like it that hot, but then my mouth hurts. Anyway, has anybody heated up soup and they put a spoon in there for you and come get your soup and you touch the spoon and the spoon's actually kind of hot?
No.
You go, wait a second, the spoon wasn't, that part of the spoon wasn't even in the soup. Nobody? Nothing like that? Okay.
Nobody.
Most spoons are good enough, they're built in a certain way, but maybe there's something else that you can think of where you reach to grab something that wasn't in a flame or wasn't getting heated up, but suddenly that part of it was. What are you thinking of, Sam?
Like, sometimes I put, like, when I'm putting a bowl of soup, sometimes we might, like, put a paper towel on, like, the bowl or something, but it's not touching the soup, but it gets hot.
Sure. Okay, well, we're going to talk about conduction some more within certain materials, because sometimes you can heat something up, like I was suggesting a spoon. Go, well, how did it get hot? Energy must have transferred to it, right? That's why it's warmer, it's higher temperature. But how did it get there? So let's take a look at that sheet. We're going to take a look at a video experiment, and it's going to show you two steel bars. You can see that in the diagram. One is labeled A, one is labeled S. I'm sorry, not two steel bars. One steel bar labeled S, one aluminum bar labeled A. And then two temperature strips. So the two temperature strips are meant to measure those two bars' temperatures. Some tape. They're going to be put in a tub of hot water, and then over the course of time, we're going to see what kind of change it is. Okay. So the setup in this, each metal bar has a temperature strip added to it. We've got the water at about 55 degrees Celsius. Can anybody estimate what that's at? Yeah, Fahrenheit.
70?
Higher than that. Usually if you approximately double it, so 55 to 110, 100, and then add 30 to it, so probably somewhere around 120, 130, somewhere in there. So hot, a little hotter than a hot tub. Okay, it's pretty warm water. The timer is going to start at 12 minutes. So here's what I'd like you to do as we watch this video, and it's only about a minute and a half long. Answer the questions on this sheet. What happened when the metal bars were placed in the hot water? And then how did the heat transfer from that hot water to the temperature strip? Which the temperature strips you're going to see are way up above the water. They're not even close to the hot water. So how'd they change? And then did the metal conduct heat? In other words, conduct, we haven't talked about that a whole lot, but did it bring heat towards it? Which metal is better for conducting? In other words, better for transferring energy. Okay, so let's take a look at the video. Minutes on the timer. Steel on the right, aluminum on the left, temperature strips way up top. Remember that hot water is about 120 degrees or so. We're seeing some change in the aluminum. Some change in the steel too. Remember this is 12 minutes, so this thing's going to be, that's why they're saying we're speeding up the video so we don't have to sit here and watch this for 12 minutes. What happened when the metal bars were placed in the hot water is the first question. How did the heat transfer from that water to the temperature strip? And which of those metals conducts heat better? Okay, take another minute and a half or so to answer those questions on your piece of paper. Another 30 seconds or so. Alright, pair up with somebody next to you, answer those 3 questions. What did you write, what did they write? What was missing, or what could you add?
The first one I put the second one I put because of how the third the second one I put the steam rises.
That's adding detail to correct answer, but answer is lacking in detail.
What'd you put for this one? I put it because it's kind of dark. Oh, okay, so second one, I put it and it rises.
Alright, let's talk about it as a group. Who's got a really good answer? What happened when the metal bars were placed in the hot water? David?
They heat it up,
Yeah, how could you tell?
because it made because it showed that the stick was getting hotter.
By what?
The rainbow theme.
There you go. They change colors, right? That's what temperature strip does. It kind of changes into different colors depending on how hot it gets. How did heat transfer from that hot water to the temperature strip? Because the water was way down here. You had the aluminum and steel bars, but way up at the top of them was the temperature strip. So what happened here? David's gonna go 2 for 2. Go for it.
So the energy from the hot water transferred onto the metal stick things, and then the energy from the stick was transferred onto the temperature.
Yeah, that's true. So we know it went from the water to the bar, from the bar to the temperature, or from the temperature strip. But how did it get all the way up to the top? Because the bar was just, the bottom of the bar was in the water. The temperature strip was way at the top. So what happened?
The hot like steam rose up and
Oh, so you're thinking maybe it was from the air. Okay.
that was
Could have been. But if that was the case, wouldn't have it been the same with the aluminum and the steel? Because it was the same water. So I don't think it was the steam. So how'd it get there? Magic.
science.
Luke.
It traveled up the like the metal, and so like as it got hotter, the heat just went up the metal bar.
So the water, and the energy in the water transferred to the bottom of that bar, but then energy transferred from the bottom of the bar to the top of the bar. I thought of another good example of that. That's happened to us when we roasted marshmallows. And you stick the very end of the marshmallow roaster into the fire because it's got the marshmallow on it, and then somebody grabs on to it lower. Ow, it's hot, right? Because that heat, even though it's just the top part by the marshmallow, that heat and energy was transferred to the top of the bar, but it traveled up that bar as well. Okay. Last one. Did the metals conduct heat? Quick answer is yeah, they did. Right. We saw a temperature change, which means they took on some energy. They took on some heat. Which metal was a better conductor? Which one did you see that had more energy being transferred to it? Kaylee.
Aluminum bar.
Yeah. Why do you think so? Trey.
Cause like got hot, like aluminum is kind of like paper, and it can like burn easily, more easily.
Okay.
I thought aluminum was better because it showed more heat. The temperature strip like was like lighting up like fireworks or something. It was like all over the place. Well, the steel bar was kind of just like a little bit at the bottom.
Okay.
Also, toaster. That's the example.
Oh, sure.
It can like it never touches the bread.
Yeah, well, let's think about this now. Take what we just talked about with this idea of conduction and some materials being good conductors. And now think about how we started, because the main question with all of this is what you see on the board. How does energy transfer to the air? Because when we first started exploring this, we talked about radiant heat from the sun, right? The sun that's millions and millions of miles away is sending its sunlight, which is energy, towards us. And we said it heats up the land, right? The rocks. It heats up the dirt. It heats up the trees. It heats up the water. But I know if I go outside today, I go, ooh, there's a lack of heat. And if I go out in the summer, I go, man, it is hot. I'm talking about the air temperature, right? So now knowing what you know about conduction, how would we say that energy transfers to the air? And I'll give you this as a clue. Yesterday we talked about the hot water particles here transferred their energy to this. And now because of that, it transferred its energy to this. And now that those had more energy, they transfer their energy to this. Think about that same thing, except for up here, instead of saying this, let's say the sun. The sun transferred its energy to the soil. The soil transfers its energy to what? Luke?
The air.
Sure. Soil touches the air. So the particles in the solid soil touch the gas particles of the air. And again, we have conduction where they hit each other, they collide, and some of that energy gets transferred. Instead of the sun transferring to the soil, you could say it transfers it to the water in the lakes. Okay, so now that liquid, the particles in the liquid just got more energy. Do the lakes and the oceans touch the air too? Sure, so those particles collide with the gas particles as well. And now the air heats up. Yeah?
I thought the sun would transfer heat to the air, or it would transfer it to the ground.
Because it's kind of coming through the air. Is that what you're saying? Well, we have the radiant energy, but then we also have energy transfer through conduction as well. So yeah, it's kind of doing both. Yeah, good question. All right, we have only 5 minutes left. I'm going to give you an assignment, and that is going to be to read a section from your textbook. You're going to read it today, and then I'm going to have a sheet for you to fill out first thing tomorrow that kind of goes back and reviews it or organizes it a little bit better. But the article itself is on, which page is that? It's called Heating the Air, Radiation and Conduction. It's on page 99. Okay, turn to that please. We'll take a quick preview of it before you get started. I would suggest that you try to take some notes on your own as you go through. What are the main important concepts? We haven't really done this before, where you've just done your own notes, but I'd like you to try it and we'll see how that goes. So we're starting on page 99, and it goes until page 104. Okay? So most of that is kind of a review or goes into a little bit more detail of some of the things that we've talked about already. So page 99 to 104, that's your assignment to read, and you guys have about 4 minutes or so to get started on that now. You may begin.